Okay, so here's the question that was tricky in the class today. So we've got y is equal to arcsine of, this should make it clearer, the arcsine of x squared. And we've got to find dy by dx. Okay, so if y is equal to arcsine of x squared, then we can say that sine of y is equal to x squared. Okay, because remember they're inverse functions. Okay, so now if I do dy of dx, okay, now I've got a functions inside a function. Okay, so what I'm going to do is I'm going to take the derivative of this times the derivative of this. Well, we know that's 2x. Okay, so we know that basically if we call u our x squared, remember our inside function, then du is simply 2x. Okay, now if I differentiate arcsine, okay, we did this in the first one. If you remember, basically, let's do that over here. If y equals arcsine of x, then that means that sine y equals x. And if I do dx by dy, that's going to give me cos of y. Now I've got dx by dy, but I want dy by dx. So what do? We flip that upside down, so that's 1 cos y. And that's what we had from part A when we did this question. So if I want to differentiate y equals arcsine of x squared, what am I going to get? I'm going to get 1 over cos of y. Okay. So now I've got 1 over cos of y, and I'm going to use my identity. Okay, remember using identity that cos squared plus sine squared equals 1. So, sorry, put this down here. Okay, so I can replace this cos with 1 over the square root of 1 minus sine squared of y. Okay, so that's I've now replaced this. Okay, and now I can multiply it by du. So I've got 2x times, and if we have 2x times, remember, basically we multiply the numerator. So that means I've got 2x times that. Now, I think that I've got sine y is equal to x squared. So my sine squared y is going to become 2x over the square root of 1 minus x squared all squared. So then that means it's 2x over the square root of 1 minus x to the power 4. And I am done. Okay, so it all relies on this differentiation of arcsine. Okay, so you can either remember the outcome that our y equals arcsine of x, then my derivative is going to be 1 over cos y, or you can basically take it from first principles and basically take the inverse function, differentiate that with respect to y, and then flip it because we want dy by dx. Okay, and basically that inverse function is a thing that lets me substitute into here using our favorite identity. Okay, I hope that's clearer. If it's not, let me know.